So let us solve one more problem on tangents and normals. So first let me read the question first. If the tangent at a point on the curve x to the power of 2 by 3 plus y to the power of 2 by 3 equals to a to the power of 2 by 3 intersects the coordinate axis in A and B, then show that the length of AB is constant. So in order to solve this problem, first we need to recall the parametric equations which satisfies x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 3. This is the eliminant of the theta from x is equal to a cos cube theta and y is equal to a sin cube theta. So that means if you consider the parametric equations and using parametric differentiation, we find out dy by dx in terms of theta, that is nothing but the slope of the tangent. Having been evaluated the slope of the tangent, easily we can find out equation of the tangent in terms of theta. So after finding the equation to the tangent, then we need to find out x-intercept and y-intercept. So after finding the x-intercept and y-intercepts, easily we can find out the length of AB using Pythagoras theorem. So this strategy has to be followed to solve this problem. First, let us solve this problem. See, just observe the solution now. Solution here, given equation of the curve x to the power of 2 by 3 plus y to the power of 2 by 3 a to the power of 2 by 3, say equation 1. Let p of a cos cube theta comma a sin cube theta be any point on the equation 1. That means this point will satisfy this equation. Even you can verify also, no problem. So if you put x for a cos cube theta, y for a sin cube theta, it quite obviously you get a to the power of 2 by 3 only. So now we can say x is equal to a cos cube theta. Differentiate both sides with respect to theta. So that means we need to find out dx by d theta, being a constant, d by d theta of cos cube theta. Let us find out the derivative of cos cube theta. Cos cube theta is in the form of cos theta to the power of n, that means n into cos theta to the power of n minus 1, and derivative of cos theta is minus sin theta. So in the similar manner, the cos cube theta differentiation can be evaluated. So this is equal to, now we get a times 3 minus 1 2 cos square theta multiplied by cos theta differentiation is minus sin theta. It's very important step. Now this can be simplified, minus 3a cos square theta sin theta. So now we know dx by d theta. So now here you see the y coordinate, that is a sin cube theta. So y is equal to a sin cube theta. So in the similar manner, let it be differentiated with respect to theta. Am I correct? Okay, let us perform the differentiation. dy by d theta equals to a times d by d theta of sin cube theta. So now sin cube theta differentiation is 3 sin square theta. The derivative of sin theta is cos theta. So we write it as like this: 3 sin square theta, differentiation of sin theta is cos theta. So now this becomes 3a sin square theta cos theta. So this is the first step has to be followed. So now This is called actually parametric differentiation. So our aim is to find out dy by dx with the help of dx by d theta and dy by d theta. So we know that in the parametric differentiation, so in the derivatives already we have discussed. So now dy by dx can be written as like this. Am I correct? Dy by d theta over dx by d theta. So that means here the dy by d theta is divided by dx by d theta, that means this value, so as to get dy by dx. So this equals to 3a sin square theta cos theta. Check it once again. Am I correct? This one divided by this one, and minus 3a cos square theta into sin theta. Now let it be simplified. So 3a gets cancelled. Here sin theta and cos theta. So we get the minus of, we get sin theta by cos theta. But for our convenience, basically the sin theta by cos theta is tan theta. So generally for our convenience, keep dy by dx like this only, the minus sin theta by cos theta. So that means now we need to find out slope of the tangent. Slope of the tangent. Slope of the tangent in general denoted by m is equal to dy by dx at theta. So that value equal to minus sin theta by cos theta. Okay. Now we need to find out equation to the tangent. So equation to the tangent, is given by y minus y1 equals to m times x minus x1. But now here we get one little bit of confusion. So what do you mean by x1, y1? That is nothing but the parametric equations. x1 stands for a cos cube theta, y1 stands for a sin cube theta. Whereas m is already known, that is minus sin theta by cos theta. So let it be replaced. So now we get y minus a sin cube theta. This is minus sin theta by cos theta. And x minus x1 stands for a cos cube theta. So in the planning session only we have discussed, we need to find out the x-intercept and y-intercept of a line. So that means we know the intercept form of a line, that is x by a plus y by b is equal to 1. That's why while simplifying only we have to keep in mind that the intercept form of a line, that is x by a plus y by b is equal to 1. So that's why now here bring sin theta this side. So now we get like this, y minus a sin cube theta by sin theta or upon sin theta equals to, this can be written minus of x minus a cos cube theta upon cos theta. So this will be very comfortable to solve this problem. So this can be written like this now. So you check it, y by sin theta, correct? And minus a sin cube theta by sin theta, that is a sin square theta. Don't get any confusion, very simple. A sin cube theta by sin theta, we get a sin square theta. In the similar manner, here right hand side also we have to simplify. This equals to minus of x by cos theta and minus a cos cube theta by cos theta, that is a cos square theta. Even you can check for a while. So now we can write y by sin theta minus a sin square theta equals to, now minus of x by cos theta. minus x by cos theta. And next here see the minus into minus plus a cos square theta. So just transpose minus x by cos theta this side minus a sin square theta right hand side. So now it becomes x by cos theta plus y by sin theta equals to a cos square theta plus a sin square theta. So very interesting fact we will get it here. So this can be written a common cos square theta plus sin square theta. The cos square theta plus sin square theta is one of the trigonometric identities. We know that the value is equal to 1. So this is a times 1 equal to a. Or multiply 1 by a on both sides. If you multiply 1 by a on both sides, we get like this. X by a cos theta plus y by a sin theta equals to 1. How does it resemble? Yes, you are exactly correct. It resembles to be x by a plus y by b is equal to 1, intercept form of a line. Now for our convenience, so let us draw a rough diagram for this problem. See, generally we get the rough diagram like this. So origin, x axis, this is y axis. Suppose this is the curve, the tangent is drawn like this. So at P point, that is a cos cube theta comma a sin cube theta. Am I correct? This is A, this is B. Now we need to find out AB. So this is actually right angle triangle. So now what does OA stand for? OA is nothing but x-intercept. So what is the x-intercept of this line? So this a cos theta OA stands for. So that means this is a cos theta. Now easily you can expect the OB is nothing but y-intercept, that is a sin theta. So this becomes a sin theta. Now we need to find out AB. Can you find out? Why not? The triangle OAB is a right angle triangle. From the right angle triangle, apply the Pythagoras theorem. So that means from figure, OA is equal to a cos theta, nothing but x-intercept. OB equals to a sin theta. Now from triangle OAB, angle AOB is equal to 90 degrees. Applying Pythagoras theorem, AB square is equal to OA square plus OB square. Am I correct? So OA square means we get a cos theta square. OB square means a sin theta square. Now what do you get it? This is a square cos square theta plus a square sin square theta. Now what shall we do it now? Yes, so now we can do like this. Here a square common, we get cos square theta plus sin square theta. Okay, the cos square theta plus sin square theta is how much? So that's 1. So now we get this is a square times 1. So a square. Since AB square is equal to a square, AB is equal to root over a square. That is a. So that means a units. A is nothing but constant. So hence the length of AB is constant. Hence, it has been proved.